SwayamPrabha. Digital India. Educated India.
Welcome to the course Product Design and Manufacturing, and the next topic of discussion is technology categories of production system. So, here we will have manufacturing operations, and then we will have manufacturing systems, we will have manufacturing support group. I am sure by this time you will be able to distinguish what we are talking about. Manufacturing support system, so here you will have two more systems. One is called material handling and identification, and you will have automation control, technologies, automation and control technologies. Then here you will have a talking with this dialogue between manufacturing operations and the supporting system, and then you will have dialogue between the manufacturing systems and the support system, and then you will have a link from here wherein which we have not touched a new topic called as quality control, and this in turn will be attached here, and this quality control is also attached with the manufacturing system, right. So, if you see here, manufacturing support group, manufacturing systems and manufacturing operations, quality control systems, and you have handling and identification. So, I can divide this into two levels. This is called as the factory level, and this is called as the enterprise level. So, these are the technological categories of production system. In manufacturing operation, we will try to see manufacturing industries and products, we will manufacturing operations, production facilities, product and production relationship. This is what are part of this manufacturing operations. When we talk about industry, the industry is divided into primary industry, secondary industry and tertiary industries. Primary industries are industries wherein which they are cultivation or exploitation of natural resources is falling under primary industries. The secondary industries are manufacturing, power generation and construction industries are secondary industries wherein which the output of the primary is converted into a useful product. Tertiary industries are those industries which are predominantly focused on service sector. So, you have to identify which industry you fall in, and accordingly you have to look forward for automation. So, in service industry you have banking, education, government, legal service, retail trades and transportation. So, when we talk about manufacturing operations, there are certain basic activities that must be carried out in a factory to convert a raw material into a finished product. Okay. So, for discrete part products, the processing and assembly operations are part of operations carried out. Material handling is one, inspection and testing is one, and the last one is coordination and control. So, these are very important for discrete part manufacturing, and in all our discussions we are more focused towards discrete product manufacturing. So, the manufacturing operation is nothing but basic activities that must be carried out in a factory to convert raw material into a finished product. When we look at the time spent in a typical metal machining factory, it is pretty interesting, and it is also an eye opener for us. Okay. So, if you take this as 100%, so time on machine, the job spends this much time on the machine, and the rest of the time it is used for moving and handling. A job inside a factory. So, what is this? This is around about 95%, and 5% is used for machining. Now, interestingly, I will divide that 5% also like this. I make it as 30% and 70%. Okay. 30% of the time is cutting, and the rest of the time is loading, positioning and inspection, etc. Okay. So, this is time on machine. Okay. So, now you see how interesting it is. The time spent in a typical metal machining factory, this is the time, 5% of the time only the object spends in machining. Out of this 5%, again 30%. So, that means to say 1.5% of the total 100% of the time which is spent by a part is spent for metal cutting. Now, here is a wonderful thing which you should all think. Should I go for CNC? Should I go for automation? Because automation will reduce this moving and handling, automation can reduce this loading and unloading. Okay. Should I spend for automation or should I spend for CNC? So, this is a trade off. Even today people buy CNC machine because it gets into a freedom of flexibility in machine in machining to produce quality output. Okay. So, this is what is pretty interesting. Please note it down, and it is also surprise. The first time when I saw this data, I myself was surprised. So, why are we going for a CNC machine? Yes, we are still going because we want a quality product and a complex geometry. Complex parts, we go for CNC machines. At one point of time where people thought of Geneva mechanism has to be made by CNC machines, today people have started making the same using template machining, and they do it on a conventional machine. So, there is a lot of changes which are happening. Even in the hard automation, copy milling is a new machines are coming up, so that it can be used for making complex jobs. When we talk about material handling and storage, it is material transport. So, vehicles such as forklifts, AGVs and monorails are used. Conveyors and hoist and cranes are used for material transport within the factory. Storage and retrieval system is also there. So, here we talk about 3-dimensional space. So, it is basically an array is made and you start dumping parts wherever you want. Okay. So, storage and system is also there. And when you talk about automatic identification and data capturing, AIDC, it is more of barcode, RFID and other techniques. Barcode is very common today. When you buy any product, you see a barcode. By reading the barcode, it is able to recognize the product name, and when you read the barcode, it also the system finds out which day it was produced and what time it was produced. Everything is there in the barcode. RFID are used for checking whether it is present, absence and slightly far off. So, there are two types of RFID. One is passive RFID, another one is active RFID. Today passive RFIDs are exhaustively used for checking whether the item is presence or absence, or it is getting moved out of a particular area or not. Inspection and testing. Inspection is something wherein which the product is getting validated. So, examination of the product and its components to determine whether they they conform to the design specifications. So that is inspection. Inspection of variables and inspection of attributes are possible. Inspection of variables are you try to measure the dimensions. Inspection of attributes are defective, non-defective, etc., etc. Testing is nothing but observing the product during actual operation or under conditions that might occur during operation is called as testing. Inspection and testing are different. Examination of the product and its components to determine whether they conform to the design specification is inspection. Observing the product during the actual product operation or under condition that might occur during operation is called testing. Coordination and control, regulation of the individual processing and assembly operations. This is part of coordination, process control and quality control. The management of plant level activities are production planning and control and quality control. So, coordination and control is also the another thing. If you go back and see, this is what we studied here. What are the different manufacturing operation, processing and assembly, material handling, inspection and testing, and coordination and control. So, these are the varying manufacturing operations which are conducted in a factory. When we talk about production facility, the production facility, a manufacturing company attempts to organize its facilities in the most efficient way to serve particular mission of the plant. Certain types of plants are recognized as the most appropriate way to organize for a given type of manufacturing. The most appropriate type depends on type of products made, production quantity and product variety. So, the most appropriate type depends on the facility, depends on type of the products to be made, production quantity and product variety. Here the number of units of a given part or a product produced annually by the plant leads to the production quantity. These are numbers which are very tentative. So, the lower production can be even 1 to 10. So, here they say 1 to 100 units. It depends on the product what we talk about. Medium is 100 to 10,000, higher production is anything above 10,000 to million. So, these are the categories generally people try to do while talking about production quantity. By looking at the production quantity, the layout of the factory is changed, the machine purchase is changed, hard automation, soft automation is looked forward and everything comes into. So, production quantity plays a very important role even in understanding the plant layout. The product variety refers to the number of different products or part design or types produced in a plant. Inverse relationship between production quantity and product variety is established in the factory automation. The product variety is more complicated than a number. Hard product variety and soft product variety are two different classifications. The product differ greatly are called as hard product variety. Small difference between the product is called as soft product variety. Here for example, number of pizzas what you buy falls under soft product variety. For example, pizza and garlic bread. Pizza and garlic bread, if you compare, it falls under hard product variety, completely different. So, when you compare amongst the pizzas, vegetarian, non-vegetarian, small, big, large, soft product variety, small difference between the products. Many common components in an assembly is used, few common components in an assembly used for hard production variety. Depending upon this, they also tries to dictate the life cycle, product life cycle. Okay. If there is a hard product variety, then it takes lot of time for establishing the assembly line or the machines. When it is soft, with some small variations it can be done. There are two types of manufacturing metrics and economic. The two aspects are production performance metrics and manufacturing cost. So, manufacturing metrics is established in production performance metrics and manufacturing cost. Production performance metrics, it talks about cycle time. How do you calculate the cycle time? If in a shift there are 480 minutes of working and if it has to produce 1000 items, if 1000 pieces has to be made, So, the cycle time is nothing but 480 minutes by 1000. So, approximately this is what is the cycle time. The production rate is Rp, the availability is A, production capacity is Pc, utilization is U, manufacturing lead time is MLT, work in progress is WIP. So, I have talked about this earlier. What is WIP? So, when we talk about the cycle time for a production operation, it is Tc is nothing but To plus Th plus T to the suffix Th. What is To? To is the processing time for the operation, Th is the handling time, T suffix Th is nothing but the tool handling time, time to change the tool. So, handling time is loading and unloading is here, tool changing time is here, and processing time is To. For a batch production, you see for a batch production, jobs of production, high quantity and flow line, how the production rate differs. So, for a batch production, the batch timing is Tb is equal to Tsu plus Q times Tc, where the average production time per work unit Tp is nothing but Tb by Q. What is Tsu? Tsu is the setting time, Q is the number of quantities, and Tc, like we saw here, Tc is the cycle time. Okay, Tc is the cycle time. So, the average production time per unit per work unit Tp is equal to Tb divided by Q. Q, what is Q? If you go back and see what is Q, Q is the quantity, right. Production rate Rp is nothing but 1 by Tp is production rate. When you try to take a job shop production, Q is the quantity which is 1. So, then Tp becomes Tsu plus Tc. Okay. For a higher quantity production, Rp is nothing but Rc 60 by Tp, since Tsu by Q is tending to 0 for a higher production. So, where the cycle time is very less. For a flow line production means assembly line, where Tc is equal to Tr plus M times To. To is the maximum processing time and Tr is the rate in which it travels. Rc is nothing but 60 divided by Tc, we are able to get it. So, this how we get the production rate. So, if we want to find out the availability of the machine is nothing but A. A is the proportion up time of the equipment. That means to say available time for machining is called as the availability. So, A can be defined as MTBF, that is mean time between failures, minus MTTR, mean time to repair, divided by MTBF. So, that gives you the availability. Okay. Mean time between failures, mean time to repair. So, let me try to explain the concept of availability. So, this is nothing but the time, okay, and the spacing is nothing but MTTR, and this is MTBF. What is MTTR? MTTR is nothing but mean time between failures, and MTBF is nothing but mean time to repair. And here is the breakdown, and here is the repair completed, and this is equipment in operation. Okay. So, with this, what are we trying to do is we are trying to teach you or explain to you what is the availability. MTTR, breakdown, repair, mean time between failures, and MTBF is mean time to repair. Next time. Okay. So, the production capacity defines as the maximum rate of output that a production facility is able to produce under a given set of operating conditions. When referring to a plant or a factory, the term plant capacity is used. production capacity or plant capacity is the same. Assuming operating conditions refer to number of shifts per day, number of hours per shift. So, number of shifts per day maximum can be 3, number of hours per shift can be 8, employment levels is the other variable. So, with this what we do is we always try to calculate the plant capacity. The simplest way of calculating the plant capacity is, the simplest case is quantity production in which there are n production machines in a plant and they all produce the same part or product, n machines. So, each machine produces at a rate of Rp. So, PC plant capacity is n products are produced in HPC into Rp. What is HPC? Number of hours in the period during which used to measure the plant capacity, which is nothing but hours per period, HPC. Okay. So, with this what are we trying to do? We are trying to calculate the plant capacity. How to adjust the plant capacity? They can be adjusted in two ways. One is over a short term period, the other one is over an intermediate or a long term period. So, how do we adjust it? Increase or decrease the number of workers, the plant capacity can be adjusted. Increase or decrease the number of shifts, it can be done. Increase or decrease the number of hours per shift, which is also done. So, decreases over time should be cut down. Over an intermediate or a long term, increase the number of machines n, the capacity can be increased or decreased. The increased production rate Rp by method improvement or by processing technology changing, automating the machine, the Rp can be increased. So, these are long term solutions, these are short term solutions. Utilization, availability is different, utilization is different. Utilization is defined as the proportion of time that a productivity resource is used relative to the time available under the definition of plant capacity. Utilization is defined as the proportion of time that a productivity resource, a machine, is used relative to the time available under the definition of plant capacity. For example, if the machine is used 60% of a shift time, so which is nothing but 8 hours. So, you can try to calculate 60% for 8 hours. So, 60 per half of is 4 hours. So, it should be approximately 5 hours, 5 point something hours is the time you operate the machine out of 8 hours. Rest of the time machine is idling, want of part or tool setting. So, this is nothing but the utilization chart. Many of the heavy industries, the utilization is less than 10%. But here what happens, because the job is very rare and it is very complex. So, machine utilization is not bothered about, because the complex part feature, the quality which is produced and the reliability which is produced matters here. So, what is manufacturing lead time? It is defined as the total time required to process a given part or a product through the plant, including any time for delay, material handling, queues before the machine, etc. Manufacturing lead time is nothing but N naught, number of operations, bracket, setting time, Q is number of batches, TC is the cycle time per part and TNO is the non-operation time. You can easily find out what is manufacturing lead time. So, what is that is manufacturing operations, there are a set of operations, the order is released, please produce that part. So, the part gets into the first machine and it keeps undergoing all the operation and it gets out. So, by the time it is getting out, so that a customer could capture it, that is called as the manufacturing lead time. You have customer lead time and you have manufacturing lead time. So, these are two different things. What is WIP? WIP is defined as the quantity of part or products currently located in the factory that either are being processed or are between processing operation is called WIP. R suffix PPH into MLT gives you that. What is RPPH is hours plant production rate, which is nothing but pieces per hour, and MLT is the manufacturing lead time. So, you can try to find out what is your WIP. WIP has to be as low as possible. lead time has to be as low as possible, the capacity has to be so the plant capacity has to be close to 100%. Okay. So, these are all the idealistic case people will try to have. When we get into automation, when I try to introduce automation, so manufacturing automation is very, very important. Automation is a technology by which a process or a procedure is accomplished without human intervention or assistance. That is called as automation. There are three elements of an automated system. One is power, another one is program, and the third one is control. So, control is nothing but actuation system. Program of instruction is nothing but what is to be done, the direct of the process. Power is the to accomplish the process and operation in automation. The power for the source is to drive the process itself, to load and unload the work unit, to transport between operations is the power's job. Power for automation is control unit, power is given to the control unit, power to activate, and data acquisition and information processing are for power for automation. When we talk about program of instructions in automation, set of commands that specify the sequence of steps in the work cycle and the details of each step is given, that is program instruction. For example, in an NC part program, every line is called as a block. Okay. During each step, there are one or more activities involved, changes in one or more process parameter. Example, temperature setting of furnace is an instruction. So, if it crosses 60 degrees, switch off. Okay. So, axis position in the positioning system is also a program instruction. Motor on off is a program instruction. Controls, there are two types of control. One is called as open loop control, the other one is called as closed loop control. Open loop control is where it is very simple and less expensive. Here the risk that the actuator will not have the intended effect. So, that is the risk. For example, you have said move. So, here is an actuator and here is the workpiece. So, when we have an open loop system, when you say move, the actuator is moving and the workpiece is moving. So, it is assumed that whatever move is given here, actuation moves so much and the workpiece is moved so much. Okay. But there can be a way when the torques are very high, there is lot of resistance for the workpiece to rotate or move. So, then there is a slip happening in the signal. So, here there is a need to have a feedback. So, those systems are called as closed loop systems. Closed loop systems are a system in which the output variable is compared with an input variable and any difference between the two is used to drive the output into agreement with the input. So, that is called as closed loop control system. Open loop control system, closed loop control system. When we talk about automation, we saw power, program of instruction and control systems, which is very important. So, we have put that the same thing in words. So, input parameter, we have controller, we have actuator, we have a processor. If there is no feedback, it is called as an open loop system. If there is a feedback, it is called as a closed loop system. So, feedback is given and every time it is compared, the error signal is given and the process is operated. So, this talks about the control system for open loop system and closed loop system. The control system, as I told you earlier, it can also be used. It can also be used for positioning. So, here is a system wherein which the position is controlled. Okay. Here is a feedback control system which is used in a CNC machine. The values are given, the controller gives the value to the motor and the motor actuates its motion. There is a coupling. So, from the coupling you can see a lead screw rotating. This lead screw will rotate and there is a nut here, the table moves in the left direction. Okay. So, suppose if there is, as I told you earlier, if there is lot of load here while machining and there is a slip which is happening, then what was intended to move by the workpiece by the table is not moved because there is a slip happening. So, that has to be recorded. So, that will be recorded by using an optical encoder. This encoder gives the signal and the error is checked here, and then correspondingly it is controlled and the motor is moved. So, this is a position system with feedback control, a one axis position control system consisting of a lead screw by a DC servo motor and using an optical encoder as a feedback. If you have an open loop system, the motor becomes a stepper motor. When to use an open loop system? When the action performed by the control is simple, we go for open loop system. When the actuation function is very reliable, we go for open loop system. When area of the reaction force opposing the actuation are very small, we go for open loop system. In the conditions do not apply, then a closed loop system will be used. 1, 2, 3 condition. If none is fulfilled, then we go for a closed loop system. What are the advanced functions in automation? One is today safety monitoring is done, and then we talk about maintenance and repair diagnostics, and error detection and recovery are some of the advanced automation functions which are given today. Safety monitoring, we use sensors to track systems operation and identify conditions that are unsafe or potentially unsafe. So, that is safety monitoring. Reason for safety monitoring: to protect a worker or equipment. If there is a dangerous thing or if the machine is running, so then if you open the door, the machine will stop. Otherwise, there is a possibility the hand can be put in and it can be hurt. The possible response to hazard is complete stoppage of the system, sound and alarm, reduce operating system of the process, take corrective actions to recover from the safety violations. So, these are the responsible to hazardous environment. Safety monitoring is there. In the banks, we used to have a burglar alarm. So, that is also safety monitoring. That is part of automation. When we talk about maintenance and repair, the status monitoring, failure diagnostics and recommendation for repair procedure, these are falling under advanced automation functions. Status in maintenance. So, status monitoring, monitor and records status of a key sensor and parameter during the system operation. For example, if the filter in the automobile is choked, getting choked, then it monitors what is the amount of fresh air it can come, and then it quickly says that okay, there is a lot of reduction. So, immediately the status monitoring signal is raised and you try to do some necessary actions. Failure diagnostics, invoke when the malfunction occurs. For example, I was recently traveling in an auto. Today there is a sensor which is fixed to the auto tires. When there is a pressure difference or when there is a disbalance in the vehicle, immediately the alarm is raised and the auto is shut down. The fuel to the engine is shut down and the auto stops. That is failure diagnostics. So, moment there is a jerk or vibration or a pressure difference leak, then immediately invoke when a malfunction occurs. Purpose is analyze recorded value, so the cause of malfunction can be identified immediately. Recommendation of repair procedure, provides recommendation. So, once you diagnosed and then you give a recommendation. For example, if that sensor particularly fails, then immediately it says please check the following items. This is what is happening today. Today when you go to car garage service centers, so the days have changed. As soon as the car enters inside a higher end car, the service engineer comes and fits his laptop into the engine, in the EMU of the engine, and then what he does is he tries to collect all the data, and when he collects all the data, the status is monitored, it is reported that these are the sensors which is malfunctioning, these are the failures which has happened, and it also says please do this to replace, and this is how the procedure is for replace. So, that is recommendation for repair procedure. The error detection and recovery. Error detection function uses the system's available sensor to determine whether a deviation or a malfunction has occurred. Correctly interpret the sensor signals and classify the error, that is error detection and function. Error recovery and possible strategies. Make adjustment at end of the work cycle, that is error recovery and possible strategy. Make adjustment during the current working cycle itself. Stop the process to invoke corrective actions and stop the process and call for help. These are some of the error recovery possible strategies. Error detection and error recovery are two important things which is followed today. The levels of automation. There are 5 levels of automation. the automation can happen at device level, it can happen at machine level, it can happen at cell level, it can happen at plant level, and it can happen at enterprise level. These are the 5 levels. Enterprise level is the highest level where corporate information is used. Plant level, the factory and production systems are used. The cell level, manufacturing cell. So, what is a cell? A cell is a closed area wherein which we have dissimilar machines which can cater to the need of producing outputs in a range. Okay. These are machines. These machines are dissimilar machines. So, like this in your factory you will have several cells. So, if one machine fails and one cell fails, only that cell is affected, but rest is not affected. So, cell or system level is within their cell, they try to have a manufacturing system automation. So, here you will have a man or a robo. This robo will try to man the machines properly. So, this is a machine, this is also a machine. Clear? So, then machine level is you try to take one machine and inside a machine you try to do automation, for example CNC machines, and device is nothing but an actuator, sensor and the other hardware components. Inside a machine you have drives, you have actuators. So, those are the lowest level of automation. Machine is the next, the cell is the third, several of these put together forms a plant, and several of these plant put together forms an enterprise. So, these are the various levels of automation. The easiest level is this, the toughest level is this. Here there is lot of data to be handled, here there is less data to be handled, less data in the sense dynamic data, time based data. So, this is how it is, the flow of data happens here. This is what is the example. Corporate information system is enterprise, production system is plant, manufacturing system group of machines is cell, individual machines is machine level, device is sensor, actuators and other hardwares. These are the 5 levels of automation. Lower one is device level, higher one is enterprise level. The amount of data handled is very high here as compared to this, because they have time based data. The CAD and CAM working together. A modern CAD CAM program is necessary for using either manufacturing CAM or engineering software program CAE. As both systems required a model in order to perform either analysis or manufacturing, we try to integrate these two. CAE is nothing but computer aided engineering, requires the geometric model to determine the integrated nodal network to use for the analysis. CAM requires a part geometry. So, a CAM software cannot exist without a CAD software. So, the CAM requires a part geometry to determine a machine tool route and cut. Both require CAD, but CAD can be used as a standalone system for engineering virtual modeling. CAD is the backbone for CAM or CAE. CAE and CAM can be interchanged and is required for the to function properly. Each software are powerful tools for engineers and machinists that make daily job function easier and more effective. Using them correctly would provide them optimum benefits for the individuals and better utilization for the company. Computer aided engineering. The computer aided engineering, the following parameters are typically used in a mechanical engineering for CAE simulation: pressure, time, component interaction and applied force. So, pressure, time and temperature are 3 major parameters which involved in manufacturing. So, in CAE we try to do that, and on top of this we also try to have interaction between the parts. Okay. So, that is what is talked about in interaction. So, if you look at the interaction of various computer aided technologies, this is the overall ellipse you have, and you can see here PLM, product life cycle management. This is CAD, whatever is there. Inside CAD you have conceptual design, product layout, you have detailed component modeling, assembly modeling, you have analysis, engineering drawing and tool. So, when we talk about tool, it comes under CAM. When you talk about analysis, it goes to CAE. So, coordinate measuring machine, computer aided quality, manufacturing resource planning, computer aided process planning, computer aided manufacturing and inspection. Okay. So, if you see here, conceiving, designing, developing and manufacturing. So, a CAD is a overlap which comes in all the area, and you try to get conceived, design, development and manufactured. When you look at CAD/CAM integration, strategic planning, production planning, then you will have calculations of material and then you will have production systems. So, this is how your product is done. So, when we talk about it, you will see manufacturing strategies, market strategy planning is here. So, which needs for simulation and which needs to look at results of simulation, calculate the material requirement and load. So, that is what it does. When we talk about production planning, it is more of performance, cost, capacity planning, technical data and require for estimates. So, here you will have design, methods and CAD/CAM. The quality, performance, how do we make, what and when to make, all these things are given by production systems. What and when to purchase are given here. So, a CAD/CAM integration integrates marketing strategy, customer order, proposals, design, quality performance and finally you produce the output. So, the entire thing goes around a single database. This single database makes a big change in the CAD/CAM integration. If you have data of different machines and if these machines could not talk to each other, then the data becomes a problem and the integration becomes a bigger problem. So, you could all do it because of the common database you have. When we talk about computer aided design and drafting is use of computer technology for design and design documentation. The biggest advantage of design is for design optimization, on top of it documentation. CAD software replaces manual drafting with an automated process. Computer aided design is the use of computer systems to aid in the creation, modification, analysis, optimization of design. CAD software is used to increase the productivity of the designer, improve the quality of the design, improve communication through documentation and to create a database for manufacturing. CAD may be used to design curves and figures into 2-dimensional space and 3-dimensional space. So, CAD is used for 3-dimensional. From the 3-dimensional you go for CAM. So, 3-dimensionally it can drawing is used for CAM analysis. So, there only we do feature extraction. So, when we talk about computer aided design, the conceiving has need or the idea, research and concept development. Then in the design what happens, you do drafting, modeling of model design we do, wherein which we use part libraries and we do analysis. Part libraries are already existing library functions in the CAD system, wherein which you automatically pull out one, add it to your drawing and start using it. And all these part functions, part library functions, these parts will have a standard CAM, that means to say a standard processing sequence. So, that is what is CAD, then analysis. You will also have assembly and then drafting. Okay. Engineering drawing. So, in the model of design you will have engineering drawing, tool design, planning and presentation. All these things are attached to that model design. So, tool design, planning and engineering drawing is given to manufacturing, presentation is given to marketing. So, this is how a computer aided design process works. These are the main subdivision: conceiving, designing, validating and manufacturing. So, in computer aided design there are 2D drawing, then basic 3D drawing, then you have sculptured surfaces, then you have solid models and engineering analysis. 2D, wireframe, sculpture, that is surface modeling, solid modeling and engineering analysis. Surface modeling we use for if you want to see along the surface what is the drag. So, you can use surface modeling, you are least bothered about the volume. When you want to do analysis like torsion analysis or load analysis, volume is very important. So, we use solid modeling. So, this is a 2D model in CAD software. You can just draw and you have not given the views. So, by looking at it, you do not know what is the thickness, you do not know whether it is a sheet or a block, you start using it. So, this is nothing but a 2D drawing. In order to have an interpretation of the 2D drawing, we try to give multiple views. By looking at different views, the author or the customer can find out what is this part. This is a 3D modeled CAD software product. So, you can see these are the parts, these are the sub assemblies, whatever it is, but here you do not get to see the dimensions, you do not get to see the assembly inside the part. So, these are 3D model in CAD softwares which tries to give us the overall impression, but you do not get much of dimensional and assembly informations. Some applications of CAD, it is used in automobile, it is used in shipbuilding industry, it is used in aerospace industry, it is used in architectural industry, it is used for prosthetics development, it is used for animation of special effect movies, advertisement and technical manuals, and digital content creation. It can be used, CAD can be used. CAM is a software and computer control machinery to automate a manufacturing process is CAM. Based on the definition, you need 3 components for CAD: software, machinery and post processing. Software tries to tell the machine how to work on the product, machinery in turn turns the raw material into a finished product, post processing converts the tool path into a language machine understanding. So, CAD to CAM process, without CAM there is no CAD. The CAD focuses on design of a product, CAM focuses on how it is to be made. You can design the most elegant part in your CAD tool, but if you cannot effectively make it with a CAM system, then you are better off kicking rocks. So, that means to say you are not getting anything. So, without CAM there is no CAD, without CAD the CAD focuses on design, CAM focuses on how to make. The start of every engineering process begins with the world of CAD. So, engineer starts with 2D or 3D to make the output. The world of CAD, any design is called a model and contains a set of physical properties that will be used by CAM. So, this is by CAM. So, the part was created. So, now the geometry details were given. Now, the tool path simulation, that is what we are talking about, the post processing. Post processing that converts the tool path into a language machine can be understood. So, this tries to use to a cutter, this cutter is going around. So, it is trying to create you parts, the path, and then you can start using it. So, computer aided manufacturing, when the design is complete in CAD, it can be loaded into CAM. It is traditionally done by exporting a CAD file into a CAM software and importing into a software, and then using an integrated software. Both CAD and CAM exists today. Once your CAD model is imported into a CAM, the software starts preparing the model for machining, and the machining is controlled, which converts into the raw material into finished product. The CAM software prepares a model for machining by working through several actions, including checking if the model has any geometrical error, creating a tool path of the model, setting any required machine parameters, and configuring nesting when the CAM system will decide the best orientation for a part to maximize the efficiency. So, checking the model, creating the tool path, setting of parameters, configuring nesting. What is nesting? If you have a flat and you want to make several holes and pierce and remove material. So, what geometry you should keep such that you will get the best out of it is called as nesting. So, computer aided manufacturing CAM, once the model is prepared for machining, all the information set into the machine to physically produce the part is done by CAM. So, after the CAM has given its clearance, then it is most probably what we focus is on producing the physical part, because the part is done, geometry is the tool path geometry is done, and then we try to take this CAM and then start producing it. However, we cannot just give a machine a bunch of instructions in English, we need to speak the machine language. To do this, we convert all the machine information into G codes as far as CNC machine is concerned. This is the set of instruction that controls the machine action, including speed, feed rate and coolant, etc., etc. So, what did we see in this particular lecture? We saw what are the world class order winning criteria, what is SIM, what are the basic types of automated manufacturing systems, what are the automation principles and strategies, how the industries are classified, how do you understand by operating cycle, production rate, availability, how do you adjust plant capacity, what are the different levels of automation, what do you understand by CAD and CAM. Okay. Task to the students. So, what I would request you is, please try to take a part where it has 5 features in it. Draw CAD model, convert CAD model into CAM model and generate the machine codes for the part. Okay. Any part you do. Second, so you are supposed to try to use wireframe model and develop a 3D part. Try to interpret the part. Okay. So, these two are the assignments. So, please do these assignments, then only you will be able to appreciate this course. So, CAD going to CAM. Here you will have neutral files that we are not covering here. So, that is what is export and import, what we talk about. Neutral files are the files wherein which converts the CAD drawing into a CAM understanding thing. And in CAM you talk about process parameters for machining along with tool path and tool. Okay. This is what it is. So, thank you very much.